Okay. So what I want to do now is just kind of continue working on some of this quadratic lesson planning stuff. I wanted to specifically look at something in Delta Math that I saw, and wanted to share it with you guys and make sure that I know how to work it out. Where we need to get with these quadratics is we need to be able to I don't know why it's taking so long, but we need to be able to solve them given word problems. Okay, so word problems are going to be the killers. We want to make sure you understand what you're being asked to do when you encounter a word problem. So let me get into Delta Math. So today I'm also trying out something new. Oh yeah, let's read this, because this guy that made this software for Delta, he told me he was going to start doing a premium version. So let's read this. As you may know, I've been a public high school teacher in New York for 13 years. Delta Math has grown to millions of users while I've worked on the site in my spare time. Okay, blah, blah, blah. 2-year-old at home, cannot do. I'm resigning my teaching position at the end of February. What? Zach, don't do that. I intend on keeping all current and blah, 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 but in order to keep my cost of living, $50 per teacher per year. Okay, click here to learn more about. All right, well, I'm sorry. I really don't want the guy to, resign his teaching position. That is really making me sad. Okay, but I mean, I'll support him. I just don't want to. I really don't want to. Let me take this off so you guys can't see me typing in my credit card number. But I really don't want him to stop doing what he's doing. He's a good teacher. I've seen a video of him. Okay, so let me just. You're going to hear my audio, but you're not going to see anything. I'm going to wait for the live stream to update to make sure that you can't see my screen. And then I'll drop that credit card in there. I mean, we have to, I'm happy to support him because he's created software that's kind of changed the way that I teach, and you guys love it as kids. So, okay, so now I see that I'm not revealing everything. Hopefully, we'll go with it. So I'm going to support this guy. Fill in your details manually. What? That makes me sad. I kind of feel like that's not a good move, personally. I wouldn't want to stop teaching just because I had something going on the side, like Delta Math. Kind of feel, I mean, maybe he's about to make a bunch of money, but I have a feeling that a lot of people will stop using Delta just because it's going to have a charge to it. Okay. Let's see. Starting to send me a code. All right, let me see what code it sent me. I'll be back on where it's visible here in a second, guys. Trying to pay this dude. Okay. Yeah, I didn't get anything. He's supposed to be sending me something. All right. Let's pay him his money. Okay. Payment was successful. You and your students will now have access to all available videos. Okay, so here's some good news. Let me show the screen again. Let me show the screen for you guys so you can see what's up. Okay. Yeah. It says your payment was successful. Thank you so much. You and your students will now have access to all available videos. When you or your student is viewing a problem, there will be a watch video link. Okay, well, let's see if that's really true. Let's go into that assignment that I created yesterday, and let's see if there are in fact videos. Maybe this is the, oh look, watch help video. Let's see what it does. Okay, so he's got a whole video where he's working out the problem. Wow. Here, let me mute that music for a second. Hang on, I want to hear it. I don't hear anything. Is there no voice? Oh, I don't. Oh, here it is. All right.
Squared, you get an x. And if you divide an x from a 5x, you just get a minus 5. So we factor the greatest common factor out. And then we see, well, if this times this equals 0, then if x is 0 or if this is 0, we get 0. So remember that if either side is equal to 0, when we multiply, we get 0. So therefore, if x itself is...
This is the guy. This is the teacher.
We will get 0 as our answer. Or if this factor, x minus 5, is equal to 0...
This is so cool.
This final answer will also be 0. So what we do here is we just add 5 to both sides. And in adding 5 to both sides, we get x would equal 5. So those are our answers. Now we could take the original equation, x squared minus 5x, and plug it in. 0 squared minus 5 times 0 is 0, because that's 0 minus 0, which of course equals 0.
Oh, he's going to check the solution. Okay.
5 squared minus 5 times 5, is that equal to 0?
I like it.
5 squared is 25, and 5 times 5 is 25, and that equals 0. So we see that the answer worked. So to type it in, we press 0, and you can just press comma, and a new box will appear for the 5. If you don't do that, you could type your first answer and then press this plus button, which makes you a second box. We're entering our values of x in set notation as the two different values in either order that x could be. So this equation, we are not set equal to 0 already, so we have to do that ourselves. So there's only one term on the right side.
Oh, I love it.
To get rid of that by doing the inverse operation.
I just love it.
So we add x to the right side, but therefore we must also add x to the left side. So the
So
x squared,
just imagine if you were having to do, hang on a second.
is negative.
Imagine if you were stuck doing homework. You've got a little button you can click now to just watch a tutorial video. Wow, definitely instantly worth the money. Let's send this guy a message telling him thank you. Okay. How do we contact him? Let me do a skill request suggestion. Say, Zach. Wow. Awesome. Tutorial video feature. Really awesome. Thank you so much for making these available.
3, 6 and 4, 12 and 2. Now 6 and 4 is interesting.
I paid the 50.
But of course, I need the numbers to add up to negative 10. Fortunately, if we make both numbers negative,
One thing,
apply to positive 24, and
I am having trouble locating
find the two numbers which multiply
problems sets to assign for graphing quadratics.
So this is an appropriate way of factoring this trinomial. Now remember,
Do you have
times this binomial
a problem? Well, what are we going to say?
itself was 0. 0 times anything is 0, and same thing with this one. So the method after factoring is to set each factor equal to 0. We set each factor equal to 0.
I am really sorry
X would make
to hear you are resigning your teaching position, but
well, that means that X is 6.
I assume
0. If the x minus
it's
4
the best decision
holding 0,
for you.
opposite of -4.
Thank you for what you have created with Delta Math.
Answers are 6, comma, or new.
And I look forward to all new features.
Now, in this case, we have 2 terms.
Wish you luck
Terms on the left. This is the term
in
vertex
this
formula.
next chapter.
So I'm going to leave that there. So we're just going to get rid of these terms.
I hope
Divide to the opposite.
Delta
The
Math
opposite of minus x is plus x.
blows up into a huge company.
But also we can get rid of our -1 at the same time. So we can do this.
Okay.
Do it one step. So the right side will just equal 0. The left side, the x squared.
Okay, so I'm totally sold. I mean, that's going to be great. So not only will you have my YouTube videos and in class and live streams and whatnot, but you'll have, remember, you've also got the ability to look at an example problem when you do these assignments. So you can see an example problem and now you can watch a video. Okay. So with that in mind, just let's take it for a spin here. Let's do this problem here. This isn't even what I was wanting to do, but we'll do it anyway. So let me screen snip this. Okay, and we'll drop it into OneNote. That is so cool. I don't think I've ever been so instantaneously happy that I spent money. Okay, I think the kids are going to really benefit from that. And if you're a kid watching this, then I would love for you to comment and let me know what you think, if you think you will benefit from that. Let me just make sure you're still seeing everything. Yep. Okay. Oh, we better put that music back on. All right, let's check the stream health. 3 viewers. Yeah, I mean, it is a Sunday morning, so. Alrighty. So let's solve for all values of x by factoring. Okay, so like Zach said, the problem right now is we don't have this in standard form. Standard form would be ax squared plus bx plus c. Okay, but we don't have it in standard form right now. If you notice, one of the linear terms is over here on the right side, and this all needs to be set equal to 0. Okay, so what do we need to do? Well, we need to, let me zoom in on this. Okay, if I want this to be in standard form, I'll need to subtract 3x from both sides. And you want to line up your linear terms. See, I've got linear terms here. This is the linear term. And so I want to line those linear terms up. Okay, so you're going to match the match those terms. Okay. So now additive inverses cancel on the right, and here on the left I've got, and see, remember there's a little 1 right here. So it's negative 1x minus 3x. We can do this. Well, that's negative 4x, right? So my new problem is x squared minus 4x equals 0. And so this doesn't quite look like ax squared plus bx plus c. But it really is like it, because the a value here, okay, is 1. And the b value is negative 4. So what's the c value? Well, if it's not there, okay, it's 0. So the c value is 0. You could theoretically write this as x squared minus 4x plus 0 equals 0 to make it look really standard form-ish, but that is not necessary. Okay. All right. So there's a trick here to simplify your life. So instead of trying to do all that complex factoring that we learned about yesterday, just think about this. Is there anything you can pull out? Think about greatest common factor. Okay, what terms can you pull out of both? If you had to divide something out of both of these terms, what would you pull out? Well, you could divide out an x from both terms, okay? And it's kind of like reverse distribution. See, so I'm going to pull the x out of both terms. So if I divide an x out of both terms, it has to go over on the left side. So now this next step, this becomes x, open parentheses, and then x squared divided by x. Well, that's just an application of the quotient rule, where you have x squared over x equals x to the 2 minus 1 equals x. Okay, so now I just have x minus, and then these x's cancel out, minus 4 equals 0. So here are my two solutions. The way you read this is you say, well, okay, x equals 0 and x minus 4 equals 0. And so to get your actual answers, you want to get x by itself in both of these little problems. So here I would just need to add 4 to both sides. So now x equals 4 and x equals 0. So these are my two solutions. That means that this, if I graphed this quadratic, this is where the graph would cross the x-axis. So these are the x-intercepts. We also call these the zeros. We also call them the roots. Okay, so if I was graphing this quadratic, here's what it would look like. Because we always want to know what these things look like in picture form. Whoops, didn't want to do any of that. Okay, so here's what it would look like in picture form if we graphed it. I don't want to switch to black. Okay, what's the y-intercept of this quadratic? Well, it's actually just 0. Okay, so the y-intercept is 0. 0, 0, right there. Remember when we wrote it out, ax squared plus bx plus c, we put a 0 there for the c, and the c is the y-intercept. So now we need to make a note. This thing's going to cross the x-axis at 4. Wait a minute. How is that going to happen if the y-intercept is 0? Ah, I made a mistake. So the y-intercept is 0, but that's not the vertex. Okay, got it. So that's fine. We can still put that point. We're still good. So that's a point. This is the y-intercept. Okay. Now let's ask ourselves a question. Consider the original problem. X squared minus, what was it? Minus 4x equals 0. Okay. So the leading coefficient of the quadratic term is 1. This is the quadratic term because it has that squared. So this is called the quadratic term. So when I say the leading coefficient of the quadratic term, this is the leading coefficient. So you know where I'm talking about in the problem. Okay, so because it's positive, because this leading coefficient of the quadratic term is positive, the graph is going to slope upward like this. Okay, if it had been negative, it would slope downward. So we're going to be seeing an upward sloping curved line. It's going to pass through the y-axis at 0, 0. Fair enough. But now we also need to note that one of those, one of the x-intercepts is 0. Well, we already plotted that. The other x-intercept is positive 4. So now I need to go back to my graph and mark off 4 places. 1, 2, I'm just trying to evenly space them. 4. Okay, so we'll just go ahead and put 5, 6, 7. So this is 1, 2, 3, 4. Here's another place where this thing crosses the y-axis. Right here at 4. I mean the x-axis. Okay, and now what should we do? We have to find the vertex. Okay, so we have to find the vertex of the graph. So remember how we find vertex? Here's the vertex formula. Okay, well, the x value, okay, of the vertex, remember you're going to have a coordinate pair. The x coordinate of the vertex is found by taking negative b over 2 times a. Okay, so we just have to know what a, basically we always have to know what a, b, and c are in these quadratic problems. So if I go up to the problem, this is my a value, okay, and this is my b value. So let's go down here and write this. A, let's do it in a different color. A equals 1 and b equals negative 4. So remember to be very, very careful about how you substitute in these values, otherwise you'll mess up. So therefore, right, x equals negative, open parentheses, and then I'm going to put the b value, negative 4, over, come on, over 2 times the a value, which is 1. Okay, so now x equals negative 4 is positive 4 over 2. So x equals 2. This is the x value of the vertex equals 2. So this 2 here, this is the x coordinate of the vertex. So you can't stop there. Now you have to use x coordinate to find y coordinate. How do you do that? Well, remember our initial equation was, once we solved it for 0, it was x squared minus 4x equals 0. So we'll say f of x equals x squared minus 4x. So now what we want to do is find f of 2. Okay. Wasn't the x coordinate is 2. So that's where we're going to take this guy here and put him. Okay. He's going to go right here. Okay. So that's where I'm getting f of 2 equals, open parentheses, 2, close parentheses, squared, minus 4, open parentheses, 2, close parentheses. So I'm evaluating the function at 2. Okay, so once again, we'll just say f of 2 equals 2 squared is 4, and then 4 times 2 is 8, so it's 4 minus 8. So this means f of 2 equals negative 4. In other words, when x is 2, y is negative 4. So that means we have a coordinate that we can plot at 2, negative 4, and that is the vertex. Okay. That also means the axis of symmetry of this quadratic graph is x equals 2. Okay, so we'll plot all that stuff. We needed to know this really badly. So now we know what the vertex is. We know it's upward sloping, so we know that the vertex, I should say here, we know that I don't like that color. We know that the vertex, okay, let's go down here and say, because A equals 1 and is positive, the vertex at 2, negative 4 is a minimum. Okay, so it's going to be, we have to know, is this the bottom of the hoop or the top of the hoop? Well, this one is minimum. All right, so now let's go use our information to plot some points. 2, negative 4 is where we need to be. Okay, so I got to plot some more points here. Let's see, negative 1, negative 2, negative 3, negative 4. I don't like that negative 4. Put that right here. So this is negative 1, negative 2, negative 3, negative 4. All right. So the vertex is at 2, negative 4 right here. So what this is the vertex. At 2, negative 4. All right. So also we learned that the axis of symmetry would pass through x equals 2. So my axis of symmetry is going to pass through this point right here. Okay. And I need to zoom, I need to use this. So here's the axis of symmetry. It's going to pass right through that point. And I see that I need to draw that point a little bit better right there. Okay. There you go. So now you kind of know everything you need to know, except, well, no, you know everything. You've got 2 points and you know that it's upward sloping. So now we can graph the line. Let's graph it in this cool color. Okay, so basically it's going to look like this. It's going to come down here and it's going to hit that point and then it's going to pivot back up. And we're trying to make it symmetrical. Right? So here's how it looks, like this. And it just goes off into infinity like that. Okay, so that's what that graph looks like. Now, what were they looking for in that problem? Because there's a lot of information here. All they wanted in that particular problem was this information here. Okay. But why waste a good opportunity to review everything? Okay, so let's go back and see what we can put that in. So solve for all values. I'm trying to figure out how do they want us to show the solution. Okay, but what do I put in there? How do I enter the values? Let's see. I'm trying to see how you actually put them in. Okay, hopefully. Okay, now let's watch. Watch. He's going to put in 0, Aha. I think he hit a comma. Okay. Oh, okay. So hitting this plus symbol makes more. I didn't know that. So here we're going to put in 0. And then we need to add a solution. Aha. 0 and what do we say it was? 4? Yeah, 0 and 4. Let's see if we got that right. All right. So much easier than the way I made it there, but you know what we did here, this is like a full solution. This is where you do everything. So you factor it, and then you find the vertex, and then you graph it. Factor, vertex, graph. And that's like the complete turn of the wheel, and that's what we should be practicing doing. We don't want to leave any part of that out of our problems. I'm not going to make you do that on every problem, because you do need to, you know, it would be terrifying if you had to do that every single time, all those steps. So we'll practice each little tiny skill, and then you need to, by the end of 2 weeks from now, you need to be incorporating all of that into every problem to be able to have a lot of flexibility with that. Now, look, here's the deal. It would be criminal to say, hey, 2 weeks from now, you're going to be an expert at this. Except there are going to be some people, I'm going to assign quite a few practice problems. There are going to be some people who rise to this challenge. I'll tell you this, there is no reason whatsoever that you cannot become an expert at this in 2 weeks. No reason whatsoever. All it's going to take is your dedication. But at the very minimum, you should become proficient at solving these both in the calculator and simple stuff on paper. So let me show you how easy it is to solve this in the calculator. X squared minus x equals 3x. All right, go to your calculator. Let me just clear the memory. So remember, the original problem said x squared minus x equals 3x. Watch this. So first we put x squared minus x on the in y1, and then put 3x in y2, and then hit second trace 5. Enter, enter, enter. Okay, that's one intersection. Let's see if it gives you the other one. No, it doesn't. Okay, so how do I want to explain how to solve this? How do I want to explain how to solve this? Oh, that's not going to work. So I think what I was hoping to avoid is having you to do any math whatsoever, but this is not going to work. Okay, so the way that you would do it is you would have to do x squared minus 4x, right? Basically, you would have to gather all the terms on one side of the equation, and then you hit second trace, and then you want to find the zeros. Right, there we go. Okay, so here's how you find those zeros. It says left bound. Yep. Right bound. Guess. It's going to tell you that one of the zeros is actually 0. And now second trace 2. And let's go over here for this one. Left bound there. Right bound there. Enter. It's going to tell you the other zero is 4. So that's how you do it on the TI. It's super simple. Now, I think there's a way to do it where you're just looking where x is 0. So look, x is 0. Where is x 0? Or you're looking for where y is 0. Okay, got it. So you're looking for all places where y is 0. If you're just looking at the table, y is 0 when x is 0. That's 1, and then y is 0 when x is 4. Now this method only works, guys, when the solutions are real numbers. I don't know what would happen if the solutions were imaginary. I haven't tried that in the calculator, but that's something I definitely need to figure out before I throw you to the wolves with those. But you're not going to see imaginary solutions on the star test, to the best of my knowledge. Okay. Now, going to take a quick break here and then come back and keep working. Okay. OBS. What we'll do here is just Okay, so now I'm back. Had to get some food. I was starting to get a little dizzy. Okay. And I had to get some batteries for that microphone that I use. Okay, so should probably go on power now. Good. What's next? Okay, so let's go back to delta and let's go find those problems that I wanted to talk about, and then I want to do star. So first, let's go to back, and no. I just want to go. I want to get out of this. I want to. I guess I'll create a new assignment. Skills, search modules. Let's see what they've got for us in terms of quadratics. Here's all the quadratic stuff and quadratic word problems. This isn't exactly what I wanted. Okay, so here's what I think I was looking for. Yes. Okay, so this is the type of question that we need to be working on. Let me grab this. And again, if you're just joining the stream, we now have help videos that we can watch for each question. So the guy that invented Delta Math, he released an update. So now we have the paid version, and with the paid version, you can watch a tutorial video about how to do the problem. So that is really cool that we can watch that. So you'll be able to not only look at an example problem, but you'll be able to watch a tutorial video showing you how to solve these problems. Okay, so we'll hide the video. Let's grab this problem here. Okay. Throw it in OneNote. Okay, a company sells widgets. The amount of profit Y made by the company is related to the selling price of each widget X by the given equation. Using this equation, find out what price the widget should be sold for to the nearest cent for the company to make maximum profit. All right, so here's the key. Maximum. This is the key word. We need to find the vertex. What this is telling me. What this is telling me is that we need to find the vertex of the quadratic. Okay. Now I know that the vertex of this quadratic will be a maximum. How do we know that? Well, let's write some stuff out here. We know the vertex will be the maximum because A is negative. And I'll explain what I mean by that. But because A is negative, it's going to be a graph that looks like this. So this point right here, this magic point here at the top, that is the maximum of the graph. Okay? So this is the maximum. And it's also the vertex. So in this case, this is the vertex. Now, which value of the vertex do we want? Because remember, the vertex is composed of x and y. Well, it says here that profit is y. Okay? So profit is y. And we want maximum profit. So we want the maximum y value. We want to know the largest y value of this graph, equation, function. Okay, what that means is we need to find hope it didn't just freeze on me. We need to find the y value of the vertex. Okay? So we need to, this one we don't even have to factor, okay? We just need to find the y value of the vertex. So remember, we're finding the vertex. So here's remember the steps for finding the vertex are find the x value of the vertex. And 2, evaluate the function at the x value. Of the vertex. Okay, so that's what we're going to do. Let's go ahead and do that. So if we're going to do that, we need to know A equals -1 and B equals 43, because the vertex x value is found using this formula. -b over 2a. Okay? So we just plug in those numbers. X equals negative, open parentheses, and then we'll put in b, which is 43. -43 over 2 times a, which is -1. Okay. So let's work that out. X equals -43 over 2. Well, what does that mean? well, I don't want to confuse anyone, but if we're going to turn this into a decimal, you just ask yourself, how many times is 2 going to 43? And it goes in 21 times, right? Because 21 times 2 is 42. And then there'd be one remainder. So it's negative 42.5. Negative 21.5. X equals negative 21.5. But we want to use this one. We want to keep this in fraction form when we evaluate our function. Okay, so now we're going to use that fraction value to evaluate the function. So now we will evaluate and then let's get the whole thing. Y equals negative x plus 43x minus 172. Okay, at x equals negative 43 over 2. Okay, so that's what we're going to do now. So we'll say f of x. We'll say if f of x equals negative x squared plus 43x minus 172. Just want to double check that that is in fact what we given. Yep. If that is what if that is the problem that we're given, then f of, and here's where we're going to put in negative 43 over 2 everywhere we had an x before. And we want to leave it in fraction form. F of negative 43 over 2 equals negative, open parentheses, negative 43 over 2 squared plus 43, open parentheses, negative 43 over 2, okay, minus 172. So this is the problem we have to work out. So once again, f of negative 43 over 2 equals negative. And then we're following PEMDAS here. So remember PEMDAS? We have to do the exponents in parentheses first. So we just leave that negative there. And then the rule is if you have m over n squared, that's equal to m squared over n squared. So we need to do negative 43 squared over 2 squared. Okay. And then we'll have to do plus, and then here we go with 43 over 1 times negative 43 over 2 minus 172. So let's work this out. What is negative 43 squared? In side work, we can say negative 43 squared is equal to negative 43 times negative 43. Well, that's going to be a positive, so let's just do 43 times 43. That's 9. This is 12. 12 and 9. Okay? Oh, no. Wrong. Let's do it again. 9, 12, and then 12, and then 16, 17, right? So is that right? Yeah. So now we'll add 9, 4, 8, 1. So that's 1849. And 2 squared is 4. So this is equal to negative 1849 over 4, which we'll simplify later, plus, and now let's do this, which we know 43 times negative 43 would just be negative 1849 over 2. So negative 1849 over 2 minus 172. Okay, so we're getting closer. So now we just have negative 1849 over 4 plus negative 1849 over 2. So we have to have a common denominator. We should do negative 1849 over 2 times 2 over 2. That way I have a denominator of 4. So I just need to take 1849 and multiply it by 2. That's 1889. Okay, and then 16 to 3. 3698 over 4. So what I'll write is negative 1849 over 4, and then it will be minus 3698 over 4, and then I got to do minus 172, which we should put over 4. So here I'll do negative 172 over 1 times 4 over 4. So what is 172 times 4? Okay, so that would be 8, and then 8, 2, 4, 5, 6. Let me just, please don't freeze. Let's double check our work. 8, and then 8, 2, and then 6. Okay, so 688 over 4. So this equals negative 688 over 4. So this is my task now. Here's the task at hand. We have negative 1849 minus 3698 minus 688 all over 4. Okay, so darn. We're basically just adding negative numbers. So this is pretty easy. We're just going to stack add 1849, 3698, and 688 and put a negative sign at the end. So whatever it is, it's going to be negative. So 9 plus 8, that's 17. 17 plus 8. What is that, 25? Yeah. Carry the 2. 2 plus 4 is 6. Plus 9 is 15. Plus 8, that's 23. That's 10 plus 12. That's 22. 3, 4, 5, 6. 6, 2, 3, 5 over 4. So this equals negative 6, 2, 3, 5 over 4. Oh, I see a problem. This should have been negative over a negative, so this would have been a positive. Okay, so this is a big mistake. Let's see if that messed up the problem anywhere. Yep, it definitely messed up the problem. So I made a stupid mistake. Back way up here, I dropped this negative 1. And so I was putting in this negative x value the whole time. I should have been thinking more clearly. What we needed to do was evaluate 43 over 2. Good Lord. Okay. So let me go through and fix things one step at a time. So, okay. That's going to stay the same, but then this will change. That's going to be positive. So this is going to be a plus. and this is going to be a plus. So that's, okay, I think that's all that changed. So the only math that really was a waste of time was this. This was wrong. So let's do this in order now. We take 3698 minus 1849. Okay, so this is 8, 18, 9, 4, 8, 1. 1849. Okay, 1849. So that makes sense. All right, so this is positive 1849 minus 688. Okay. 1161. So I think my answer is 1161 over 4. And now we should, this is going to be dollars, right? So we should probably go ahead and perform the division. 1161 divided by 4. 4 goes into 11 2 times. That's 8, 36, 9. Okay. 9 times 4 is 36, 0, 1. Nothing there, period. Bring down a 0. 4 goes into 10 2 times. 8, it's going to end up being 25. So 290, 25. $290.25. That is my answer. And let's see what that means so we can interpret it. What price the widget should be sold for. So this is what we found. We found the selling price of each widget that will maximize the profit of the company. Okay? So we can make a little sentence here. If the company sells each widget for $290.25 each, they will maximize their profit. Okay. Let's go see if that's right. 290.25. So we're going to put in here 290.25. Watch it be wrong. No, it's not right. Okay. To the nearest cent. Let me go back and look at the math. Oh, wait a minute. Oh. I should have gone with the X value. So, okay, so I see what I did here. Look at the graph. So, okay. That's interesting. Let me capture this window here, because we're going to learn something from this mistake. So, okay. Let's do a postmortem on this. Let me make sure I understand how this graph is set up. So profit is Y, price is X. I just didn't read the problem. So, got it. The Y-axis is profit, and the X-axis is price. And in my head, I had these axes flipped. Okay, so we already found 21.5 way back here. So this was a much easier problem than I thought. So as a matter of fact, this was the answer. Okay. So this is the maximizing, we should say profit maximizing price. Aha. So let's go down here and talk about what this value is. This is the profit the company will earn if they price each widget at $21.50. Got it. So here, let's do this. If the company sells each widget for $21.50, they will maximize their profit. And the profit, we weren't asked this, but because we worked so hard to get it, the profit will be $290.25. Okay, got it. So, okay, so what is the lesson? Read carefully is the lesson, because I even highlighted the word profit as Y. So, selling price of each widget, look. Why is this so small? Okay, selling price of each widget. And look, they tell us that the price is X. They tell us the price is X. Can't believe I made that mistake. But I made two mistakes in the problem, so this wasn't my finest hour. Okay, but we did figure it out after we got it wrong. Okay, so that was interesting. That was a good problem. There was a lot of side work there. We could have stopped right there. So price is the X value. And you know why I'm finding this confusing is because in economics, here's why I got confused. When you take your economics class, oh Lord, when you take an economics class, you learn that the y-axis is price and that the x-axis is quantity. Okay, so that's why I was messed up here, because this is a profit graph and this is a supply and demand graph. So this is called the supply and demand graph. So I was really bringing in information that was irrelevant. This is irrelevant to our problem. So I just should have read more carefully. That's why I got that wrong. Okay. That was really cool. Okay, so that was some fun math. And what should I do next? Let's see. Where's that delta math? There. Did I close it? No. It's right here. Okay. All right. So now I know what to do. The price of each widget. Okay. And then I think they have, okay, there. We have a rocket launched from a tower. The height of the rocket y in feet is related to the time after launch, x in seconds. Using this equation, find the time. So all they want us to do is find out what the x value of the vertex is in these problems. So this is a cool problem here. Let's do this one really quick now that we know what to do with these problems. Let's go check this out and solve it real quick. Okay. Let's paste this in here. I love these problems. This is actually like physics. Okay, so this is a problem. And, okay, so all we want to find is the time. And it says time is x in seconds, okay? So the height is feet. And the height is y. It says here height is y and time is x. And they want to know the time. Find the time. So here's what we do. All we have to do, ladies and gentlemen, is negative b over 2a. So a is negative 16. B is 124. They should ask the height. That would make the problem much harder. So now we just plug this into our formula. Negative b, that's negative 124 over 2 times a, which is negative 16. So it's just negative 124 over negative 32. So it's going to be positive. 124 over 32. I guess we just have to do that. So let me try factoring it. 60 times 2 would be 120, so 62. So it's going to be 2 times 62 over 2 times 16. So that simplifies a bit. And then 31 times 2 over 8 times 2. Cancel, cancel. So now I've got 31 over 8 seconds. So let's just figure out what 8 goes into 31 3 times. So say 31 over 8 equals, 8 goes into 31 3 times. So that's 24 and 7/8. So 3 and 7/8 seconds. I guess we better fill out. It wants to know to the nearest hundredth of a second. So let's do 7 divided by 8. Right? So 8 goes into 78 times. That's 64. 6. So 8 goes into 60 7 times. That's 56. Okay, and then 8 goes into 45 times. So 0.875. And they want it to the nearest hundredth of a second. So we're going to say 0.88. So this means that 3.88 seconds until No. So at 3.88 seconds, this is the time. This is the time that the rocket will be at its peak height. See, if I have so I'm not going to put that in yet because it's wrong. If I have a graph here, okay, and this thing is launched, it's going to be launched from a height. So this is height on the y-axis and time on the x-axis. So what we're saying here is there's some quadratic and it's going to be like this. Boom. Okay. Right here, this is the vertex. So this is 3.88 seconds. Well, what we want to find is this point right here. Okay, so what is this seconds? Aha. So I don't want to find the vertex. I want to find where y is 0. I want to know, so we're just going to put a 0 here and solve. By factoring. Okay, so here's what I want to do. Negative 16x squared plus 124x plus 50. So here's the equation. Y equals negative 16x squared plus 124x plus 50. Okay, and what I want to do is factor this. Now, first I'm going to replace y with 0. So 0 equals negative 16x squared plus 124x plus 50. What would be the easiest way to factor this? Maybe by completing the square. Yeah, I mean, easier than factoring by grouping because these numbers are going to be huge. Okay, so I'm going to show completing the square even though we haven't learned it yet. So if we're going to do completing the square, to solve. So first we say negative 16x squared plus 124x plus 50 equals 0. First we subtract 50 from both sides, and we get negative 16x squared plus 124x equals negative 50. And now I'm going to divide every single term by negative 16. So now it's x squared plus, well, x squared minus 124 over 16x, and we'll reduce that fraction in a second, over 50 over 16. So let's do this. What we're going to do is take the square of half the middle coefficient, but first I want to reduce the fraction. So 124 over 16, let's reduce. So 124 divided by 2 is 62, right? Yeah, over 8. Oh, didn't we already do this? And then it's 31 over 4. If we divide by 2, 31 over 4. Yeah, okay. So now we can say x squared minus 31 over 4x equals, and then here we can divide both by 2. So this is 25 over 8. All right. So now we take half the middle coefficient. So you take negative 31 over 2 and you multiply it by 1/2. And that equals negative 31 over, take negative 31 over 4, multiply it by 1/2. That's negative 31 over 8. And then you square it. So now you have negative 31 squared over 8 squared. We got to figure that out. 31 times 31. 1339. Here we go. So it's 961. I just want to check my math that is right. 31 and then 93. Okay, so 961. And 8 squared is 64. So this equals 961 over 64. All right, so now we're going to add that to both sides. And now we've created a perfect square binomial on the left side. You have x minus 31 over 8 equals, and now we have to do this. So we need to multiply both of these by 8. So what's 25 times 8? 40. 16 plus 4 is 20. So it's 200. Okay, equals 200 over 200 over 64 plus 961 over 64. So let's add those together. 961 plus 200 equals 1161. Okay, all over 64. All right. So x minus 31 over 8 equals 1161 over 64. And now we add 30. No. This is squared. Okay. There. So now we take the square root of both sides. All right. And we now have x minus 31 over 8 equals the square root of 1161 over 64. So we have square root of 1161 over square root of 64. So we got to figure out what the square root of 1161 is, which we can do. X minus 31 over 8 equals square root 1161 over 8. And we should always be saying plus or minus here. Okay, so what is the square root of 1161? What is 1 plus 1 plus 6 plus 1? 2, 8, 9. So it's divisible by 3. So we should do 1161 divided by 3. 3 goes into 11 3 times with 2 as a remainder. 3 goes into 26 8 times with 2 as a remainder, and then 7, 387. Okay. How about 387? That's 11 plus 7 is 18. So this is also divisible by 3. Nice. So that's 1, and then 2, and 9. 129. This is still divisible by 3. This is 43. Okay. Is that right? Yeah. So how am I supposed to do this? Oh, we got a viewer here. Yo. All right. So 43. That's not a perfect square. Isn't that a prime number? Did I do this right? Do you think he would really want us to do this? So let me just go with it. So this is x minus 31 over 8 equals plus or minus the square. Well, I can write here, can pull out a 3 and say plus or minus 3 square root. And then I just do 3 times 43. So 3 square root 129 over 8. And now we're going to add 31 over 8 to both sides. So x equals 31 plus or minus the square root of 129 all over 8. Oh, this cannot be, I feel like I'm doing something really wrong, but let's see where it takes me. So this equals, and then I'll have to use calculator here. This is 31 plus or minus, and then what is the square root of 129? 11.336. I'll just put 35781. Let me check something here before I give up completely. 1161. Okay, so how about that over 8? No, I don't like that. Wow, could it really be this hard? X equals 31. Okay, plus or minus 34.07345 over 8. So my two solutions, I'm going to have two of them are going to be 31 plus 34.07345 over 8. And 31 minus 34.0734 over 8. Now we're going to be able to disregard the second solution because we only want positive solutions for this one because it's because of time. Okay. So let's figure this out. We'll do this one right here. Okay, so plus 31 divided by 8. 8.134. So this is approximately equal to 8.13418 seconds. They said they wanted it rounded to the nearest hundredth. So that would be 8.13 seconds. Wow, if that's the answer, I'm going to be shocked. .13. Unbelievable. Unbelievable. Wow. That. Now, I should say this. Now, in the calculator, before everybody freaks out and says, oh, you're going to make us do that problem. I mean, look at this problem. So this was the math required to do that problem. So a rocket is launched from a tower. Okay, here's the graph. So this right here we found was 8.13. Okay, that's right here. 8.13. That's when it hits the ground. When it hits the ground. Wow, 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 wow. Look at all this math. And I got to where I had to use a calculator because I couldn't take the square root of that in my head. There's a way to do it by hand, but yeah, I don't want to do that. But let me show you how to do this in the calculator because this is really easy in the calculator. We just put this in to y equals negative 16x squared plus 124x plus 50. Negative 16x squared plus 124x, right? Plus 50. Now, we're just going to graph it. and you're going to have to find this 0 second trace 2, and you're just going to go over here. Oh, there it goes. So here, enter, and there. So do you see how quick that was? It took like less than 30 seconds to get the answer on the calculator, 8.13. So, yeah. I'll definitely be showing you guys how to do that on the calculator. This looks more appropriate for like Algebra 2. But I mean, you could do it. It's just going to be really hard. And we got bigger fish to fry. Nobody's going to ask you this question on the STAR test. And if they did, you would want to use a calculator because it would take way too much time to do by hand. Okay, well, that was interesting. I really thought that was going to be wrong. So I was really doubting myself there. Yeah, hang on. Let me respond. I was shocked. It was correct. Okay, so now let's switch gears a little bit. Let's get away from delta for a second, and let's go to star. Okay, whoa. Let's go to number 12 on the STAR test. And Jonathan, you do this one too if you can. Okay. Now, Jonathan, I know you're watching. Do you have, let me ask you a question. Do you have a graphing calculator emulator installed on your phone? Reply in the chat. So the reason there's silence is because there's a lag. There's like a 15 or 20 second lag, so I'm waiting for him to respond. Okay. Are you using an iPhone or are you using Android? Right, but what kind of smartphone do you have? Samsung. Okay, so you're using an Android device. Okay, so here's what I want you to do. Go into the Google Play Store. Download Wabbit Emu. Because that Wabbit Emu is going to emulate the TI graphing calculator. Okay, while Jonathan's getting that, I'm going to set this, I'm going to kind of like talk about this problem a little bit. Here, the graph of the quadratic parent function f was transformed. I'm going to just check the teak on this. What is the teak on this? It's teak 7c. Okay. So this is, uh-oh. Don't freeze, man. Don't freeze on me. Okay. This is teak 7C. And was this a readiness teak or a supporting teak? It's readiness. And what is the teak exactly? Determine the effects when f of x is replaced by for specific values. Okay. So transformations. All right. So this is going to be transformations. First, we need to understand what the parent function means. So parent function, what does that mean? Okay, we need to draw it. So the parent function looks like this. This is the parent quadratic x squared. Okay, so the parent quadratic function is y equals x squared. And here's how it looks. It looks like this. Okay. And so what's happening is it's transformed to create the graph f of x plus 2 minus 5. All right. So what we're going to say here is we're going to say here f of x equals x squared. Okay. So now they're saying f of x plus 2 minus 5. That's what g of x equals. Okay, so what it's saying is f of x plus 2 minus 5. So if we put in 0, f of 0 plus 2 minus 5. That's not how that works. It's shifted down by 5. Okay, so I think I got it now. So you take your x value and you square it, and then you subtract 2 from that, and then you subtract 5 from that. So if it's 0, that's 0 squared minus 2 minus 5. So that would be at -7. So the y-intercept's at -7. Is that right? No. Yeah. Yeah. All right, we gotta figure this out. Oops. So I don't know what the answer is yet. Let me figure this out. So Let me just try f of 0 plus 2 minus 5. Huh. Oh, I think I got it now. So it's f of 0 plus 2 squared. Okay. So 0 plus 2 squared, that would be 2 squared, which equals 4 minus 5 equals -1. Yeah. Okay. Now I got it. Now I figured out what to do. Let me erase this. Just a little bit confused about what to do there. Okay. So it says here the graph was transformed. G of x was transformed, or f of x was transformed into g of x, where it's now f of x plus 2 minus 5. Remember that whatever goes in here, is squared. So the math would be g of x, well, g of, let's try 0 here. G of 0 equals, open parentheses, well, let me keep it as x so we can understand. This is equal to x plus 2 squared minus 5. So g of 0 equals 0 plus 2 squared minus 5. So g of 0 equals 2 squared minus 5. G of 0 equals 4 minus 5. G of 0 equals -1. Let me show that longer. Yeah, I find this to be super confusing because I have to keep remembering that f of x equals x squared. So everywhere you see f, you need to think x squared. Okay. So if f is, what was it, x plus 2? That means f is, open parentheses, x plus 2 squared because of this. So let's see what happened to the graph. All right. Here is our parent function. It looks like it was shifted to the right 2 units. And it was shifted down 5 units. All right, see that? So we didn't have to do all that math. We could have said this means shift right 2 units, then shift down 5 units. The thing you had to know starting out was that the parent function you had to know the parent function was x squared, and you had to know what it looked like on a graph. You also had to know that adding values to x in the parentheses shifted the graph right, and subtracting whole numbers push graph down. So those are the things that you needed to know to do that problem. That was a tough one. That was a tough one right there. That was a tough problem right there. Okay. So I think I should just come up with a whole bunch of these. Like, for example, we should do graph of the quadratic parent function was transformed to say g of x equals f of x minus 4 plus 6. G of x equals f of x plus 3 plus 9. G of x equals f of x minus 6 plus 1. G of x equals f of x plus 3 minus 2. Like, we just create a bunch of examples and do them. So we learn what it means to shift around, because you really don't need to do any math. You just need to know the rules for shifting. So inside the parentheses, if there's a negative value after the x, it shifts to the left. So negative minus 4 would be shift to the left 4, and then plus 6 go up 6. So every point goes left 4 and then goes up 6. For the second one here, the second example, f of right here, every value moves right 3 and up 9. And then for the third example, f of x minus 6 plus 1, every value moves to the left 6 and then goes up 1. Wait a minute. I could be doing this all wrong. Wait a minute. Maybe adding 3 shifts to the... Hang on. We better get this one under control. Okay. We're not done yet, Jonathan. So now I need to find out where y would be. G of of maybe -2. Okay, so that would equal, wait a minute. Here's what I need to know. If g of -2 evaluates to -5, then I did it wrong. No, that's going to mess with me too. I need to look at g of -4. And at g of -4 is 0, I did this wrong. But then I'll understand what we do right. So g of -4, that's going to equal -4 plus 2 squared minus 5. So g of -4 equals -2 squared minus 5. So that's 4 minus 5. That equals -1. What? Yeah, I did this wrong. What's another value? Let's try g of -5. Let's see if g of -5 comes out to be 4. Okay, so I did it wrong. Okay. Here's the problem. This means shift left. I knew it was backwards. Left 2 units. So here's the deal. Here's the original parent function. If we see here, it was shifted left 2 and then down 5. There, it's H. Bet you $1 million it's H. So when it's, all right, so here's some rules. Means shift 2 units left, f of x plus 2 minus 5 means shift 2 units left and 5 units down. All right, so that, let's go check that one, number 12. Let's see if we were right on that. Is number 12 H? Yep, it's H. So at least we got it under control. I'm so glad that we're doing this exercise right now and we're not waiting for me to figure that out in class. Oh, that would have been a nightmare. Okay. So now we know our rules. So if it's plus, you move left. If it's plus, you move left. If it's minus, you move right. So it's backwards than what you think. Okay. Wow, there's a lot of writing on this page. Okay. So if we go back to these examples, this means shift right 4 and up 6. Right, this is left 3 and up 9. Right 6 and up 1. Right 3, left 3 and down 2. Okay, so this is shift right 4, up 6, left 3, up 9, right 6, up 1, left 3, down 2. That's what these mean. Yes, exactly, Jonathan. It is backwards. Oh boy. Let's go look at number 14 now, and I'm going to leave it on 14. I'm going to take a little break. So, Jonathan, see if you can solve this in number 14. See if you can solve this in your calculator, your Wabbit Emu. So what you're going to do is, the very first thing you're going to do is do, wow. Hold up, bro. We're going to do 4x squared plus 12x equals 135. The only thing you have to do before you go to your calculator is subtract 135 from both sides. Okay? And you get 4x squared plus 12x minus 135 equals 0. So what I want you to do is put this, okay, put that in y equals, and then hit second trace 2 for 0. Okay, and then see if you can figure it out, and then I'll show you when I get back. Okay, I'm going to take a little break because I'm exhausted. I've been going at this for like 2 hours. Let me just check the stream health, and then I'll put it back on this page for my break. Let's go back and check the stream health. Oh, I've got that open in Edge. Okay. Cool. Awesome. So let me go back to, let me just check everything. And I'll put on the audio. I guess I never started that back up. Oh, it's okay. Just need to replay it. Huh. There it goes. Okay, so now you should be hearing audio. Let me turn off my mic and take a little break. Okay, now I'm back. And I'm going to lower the volume of that music. Okay. So, let me lower it some more. There. So it's in the background, but it's not like overwhelming our ability to communicate. Okay, let me show you how to do this. I got some candy so I could fuel up here. We're going to go to the calculator app and go to y equals, clear everything out in there. Then we're going to put this whole thing in 4x squared plus 12x minus 135. Okay. Now, if we graph that, we see it crosses the x-axis in two places. We want to know both of those places. The way we find that, these are called the zeros. So the way we find it is we hit second, trace, and then go down one and get 0. And now it's asking us for the left bound, the left boundary of the first 0. So we want to find out where our little dot is. I can't see it right now. So let me zoom out. Turn off. I want to turn off second. I want to zoom out. Okay. So now I want to do second, trace 2. And I want to find that left boundary. Okay, see that? Now I'm to the left of where it's crossing the x-axis. So I hit enter, and it creates a little dotted vertical line. And then I'm going to hit right until I'm below the x-axis, and then hit enter again. And now I've got the left bound and the right bound of this point, and I hit enter again, and I see the zeros at negative 7.5. Okay, so that's one of our answers. What is the positive solution? So we found the negative solution. The negative solution is negative 7.5, but that's not our answer. We want the positive solution. So let's go back, and we'll do this again. Second, trace 2. And now I want to be over on the right side of the graph. Over here. Because I want the positive solution. So see, you have to keep hitting the right arrow until you see this guy blinking beneath the x-axis. You want to find this point. So let me zoom in on this so you can see better what I'm doing. Well, that's not what I wanted to do. I want to zoom in right where it's up here. Oops. Well, now I've screwed it up. There. So now I'm going to hit second, trace 2, and just keep hitting the left or the right arrow key until you see that little, oops, there it goes. You want it to be below the x-axis. Hit enter. You see that little dotted vertical line. Now you want to hit right arrow one time. Now you're above. Hit enter again. Okay. Now you found the left and right bounds, and you're going to guess the 0 is 4.5. Okay. So now we go back and we say our positive solution is actually 4.5. Okay. Yes. Correct. And I should say you will probably be able to read it if you're doing a graph. But this is the way you have to do it. If they only give you an equation. Good job, man. I am really impressed. Okay. All right, so we get that. Let's see what else they've got in store for us for in terms of quadratics. Why is it so slow? Okay, so number 19 is 8b. And what's 8b about? Okay, reasonable fit. Okay. So number 19 is 8b. Let's go look at number 19. Okay. This is a cool question. Oh, okay. Okay, see you later. I'll probably still be streaming by then. So here we would just use quadratic. This gives me a chance to take a break since the one viewer is going to leave. I'll just end this stream here because my computer is really slowing down on me.